Morning, class. This is Mr. DeMarco with another lesson. I hope you had a great weekend and thank you for completing those worksheets. I will have those answers posted for you later on today. The topic today is pH, and pH is a concept in science that you've learned back in 6th and 7th grade, and you just develop it more as you proceed through high school. Well, in chemistry, we get a good representation of what pH actually is. P is the measure of, and H is what we're looking for. So the measure of the amount of H plus dissolved in solution is what pH is all about. Notice that this H plus ion comes from our acid studies. But what we have to remember is in every solution, there's not only just H plus. There is H plus and OH minus ions at the same time. It's the amount of varying concentrations that determines if an overall solution is acid or base. Now, in our labs, we tend to look for pH. It's easier. But you also need to be aware of that there's this thing called pOH. And all pOH is the measurement of the hydroxide ion instead. We focus more on the H plus ion in our studies. Now, why is it the H plus ion that we look for most often? As you can recall from your earlier science classes, the pH scale is based from 0 to 14 on a 14-point system. And what you might remember, and if you don't, we'll talk about it today anyway, is that anything below 7 is considered an acid. And if you are an acid, you could be a strong acid or a weak acid. And the stronger acids have a pH closer to 0. The weaker acids are closer to 7. On the flip side, we have our base. Bases go from something above 7 to 14. And notice here that the strength of the base, strong bases are closer to 14 and weaker are closer to 7. So in analyzing our pH scale, anything that's weak is going to be around this region and it's close to 7. Now, that's basic pH. We need to know more. In chemistry, we learn about the ions that make something an acid or a base. And it's the varying amount of those ions that tells us where we are on this scale. So if we examine acids, acids have the H plus ion. And remember that when H plus reacts with water, we get H3O plus, the hydronium ion, and these two things are synonymous. Well, if I'm an acid, these H plus or H3O plus ions will be very high. OH is going to be low. And down here at a pH of 0, I'm going to have the highest amounts of H and H3O plus. And as I slide closer to 7, my concentration of H plus begins to decrease. That tells me once I get past 7, my OH starts to climb. And as I get closer and closer to a pH of 14, I have the highest hydroxide ion concentrations. Notice though, I still have the H plus ion there. Remember, if you're a base, H plus is low, OH is high. If I'm an acid, H plus is going to be higher, OH will be lower. Now, if you see the connection, we see H and OH together. Well, take a look here. At a pH of 7, we know 7 is neutral. At a pH of 7, we have equal amounts of H plus and OH minus ions. This is why in neutralization reactions, when I take an acid and a base, I make water and salt. This is also why when we write our neutralization reactions of acid and base, water, salt, I can determine if the resulting solution will be a pH of 7, or will it be a little bit below or a little bit above based upon the strength of my acids and bases. When we take a look at the pH scale, we go from 0 to 14. Now, normally we see a 1 number change that's occurring as I move up or down the scale. The major misconception of that is it doesn't just change by 1. Every change in pH changes the concentration by a factor of 10. So 6 to 7 is a 1 number change, but it actually means for us, the concentration of ions has changed by tenfold. So if we understand this concept, I can do it two ways. I can make it more of a mathematical thing. If pH is changing by a factor of 10, I can find the pH of a solution mathematically by taking the negative log of the acid solution, or H plus ion. If I want to ignore that, I can also, because we really don't need a calculation if we understand what the factor of 10 means. Log puts something to the base 10. And notice if I'm to the base 10, that also makes me a factor of 10. Now, what does this all mean? When we take a look at questions, we need to know what's acid, what's base. And when I'm comparing two numbers on the pH scale, which one's more acidic, which one's more basic, and more importantly, how many more times it's stronger or weaker. In this first example, we have a pH change from a pH of 5 to a pH of 7. Now, what does that mean? I already know that a pH of 5 is acid, and I know that a pH of 7 is neutral. But what does that mean in comparison? What that means is, as I analyze a solution with a pH of 5, and I transition to a pH of 6 or a pH of 7, that's a 2-number change. That means 5 to 6 changes by a factor of 10, and 6 to 7 changes by a factor of 10. So I understand that it's 10 times 10 tells me the strength of the ions in solution. So a pH of 5 is actually 100 times stronger in hydrogen ions than a pH of 7. I'm going up 5 to 6 to 7, so my H ion concentration is going down. If I was going below 5, I would be increasing. Now, we can take these types of questions and also make them into scenario questions, just analyzing pH a little bit further. I can take a look at this question. A garden has an acidic soil composition with a pH of 6. So I know it's below 7. I know it's an acid. It's not that strong. It's closer to the weaker side. But then I add a basic fertilizer, and the H ion changes by becoming 10,000 times weaker. What will the new pH of the soil be? Well, I know it's starting off as 6, which is a weak acid. I'm adding a base, and it's changing 10,000 times weaker. So I want to make note of how many times and how stronger or weaker it's going to be. So 10,000 times weaker. Now, what does that mean? Well, if I know I'm changing by 4 zeros, 10,000 has 4 zeros, that tells me there's going to be a 4-number difference. 1 number difference for each zero. Now, we are becoming weaker in acid. So that means I'm going to be sliding up the scale, and that's going to tell me I'm going to be a pH of 10. Notice 6, 4 zeros, 4-number difference. I'm getting weaker, so I'm going up the scale. Answer, pH of 10. Now, we can also analyze that more specifically and with more detail. So if I draw it out, I go 6 to 7, 7 to 8, 8 to 9, 9 to 10. Well, what does that mean? A 6 to 7 is a 10-fold change, 7 to 8, 10-fold change, etc. So if I went from 6 to 8, that's 10 times 10 is only 100. 6 to 9 is 3 tens, 10 to the third. 10 times 10 times 10 is 1,000. And then if I go to the fourth, 4 tens, 4 zeros, notice I get 10,000 times difference. Now, again, these questions are not that challenging, but if you lose sight of what's acid and what's base and where the strong and weak parts are, you will make silly mistakes. So you have to be careful. So like we did last time, now that we have our information, I want you to go ahead and work on the worksheet that I'll post as well. And then submit it back to me. I'll check it. And then once I get everyone's answers back in, I'll send out the answer sheet. Good luck. And remember, you could always go back to this video, watch it a couple times if you're making silly mistakes. Take care.